Hello again, and today we're going to talk about section 8.2, which is where we test a claim about the proportion. So when we're looking at hypothesis testing for proportion, we need to make sure that we have the simple random sample, we have all four conditions for a binomial distribution are satisfied, and we need to make sure that we have at least five successes and at least five failures. Now, this is a little bit different from when we did the confidence interval because the five successes and failures are based off of the null hypothesis. This is not based off the sample proportion. If all the assumptions are met, then we can do the hypothesis test using the test statistic formula given below. So for this example, we want to test the claim that fewer than 30% of adults have sleepwalked. So I always like to at least highlight or underline the claim here. So based off of an article that we have, there is information that 29.2% of 19,136 American adults have sleepwalked. So just quickly going over the assumptions here, we have to assume that this is a simple random sample. I assume we have the four conditions for a binomial distribution, and we do have at least five successes based off of the null hypothesis proportion. And I think it's pretty clear to see that we have at least five failures as well. So now what I'm going to do is I'm going to go ahead and write the null and alternative hypotheses. Since we're dealing with proportion, we can say that the claim says that fewer than 30% of adults, so that would tell me that that is our alternative hypothesis. So our null hypothesis is simply that p is equal to that same percentage. And again, just a reminder that we use the same percentage for both the null and alternative hypothesis, and that we do not use the sample proportion in either one. Our significance level in this case is 0.05. Then, using the test statistic formula, we get the test statistic to be negative 2.41. So the critical value that gives us the area of 0.05 to the left of it is negative 1.645. And if we compare that with our test statistic of negative 2.41, we find that this does, in fact, lie in the rejection region. So we will reject the null hypothesis in favor of the alternative. Similarly, if we do this for the p-value approach, we find the area to the left of our test statistic, and that gives us a p-value of 0.0080, which is in fact less than alpha, so we reject the null hypothesis in favor of H1. So in conclusion, we have sufficient evidence to support the claim that fewer than 30% of adults have in fact sleepwalked. Now I want to show you another way that you can do this using Excel. So in this table that I have set up here, we can actually just go ahead and type in the null hypothesis proportion, the number of successes based off of the sample, and the sample size, and then we determine what the alternative hypothesis is. So the proportion in the null hypothesis is 30% or zero point 0.3. The number of successes we get from taking 19,136 times 0.292. Now, of course, this didn't give me a number because I need to put equals here. Now, this is where I'd kind of advise against having decimal numbers. Typically, your number of successes will always be a whole number. Now, this is just not a whole number in this case because of some rounding errors when they came up with 29.2%. So I would prefer writing this as 5588. Lastly, the sample size is 19,136. And this was a left tail test, so we need to select the middle option here. And notice that this gives us the test statistic. The p-value is also very close to 0.008. And the p hat is just the sample proportion, which again was stated in the problem. In this example, we're looking at the probability of the ball landing on red. Now, if it's based off of chance and assuming that this is a fair wheel, the probability should be 47.4%. A gambler has been studying a roulette wheel and observed that out of 200 spins, about 93 of those had the ball land on red. At the 10% significance level, do the data provide sufficient evidence that the ball is not landing on red the correct percentage of the times for a balanced wheel? So the null hypothesis is that the proportion is equal to 47.4%, and in this case, this is actually the claim. So the alternative hypothesis must be that the proportion of the times that the ball lands on red is not equal to 47.4%. So the problem states the significance level is 10%. In Excel, we can figure out what the test statistic and the p-value is just by typing in the information that we're given. And we find out that the test statistic is negative 0.25 and the p-value is 0.7988. Notice this p-value is in fact greater than 10%, so we would fail to reject the null hypothesis in favor of the alternative. Also, we do the critical value approach. We find that our critical values are negative 1.645 and positive 1.645 because this is a two-tailed test. And we got these values by taking our alpha, dividing it by 2, and that gives us the area in each tail. And seeing that our test statistic is not inside either critical region or rejection region, we would fail to reject the null hypothesis in favor of the alternative. So, in conclusion, we do not have sufficient evidence to reject the claim that the probability of the ball landing on red is 47.4%. Something to keep in mind is the way we interpret the conclusion does depend on where the claim is. Since the claim is in the null hypothesis, we are trying to either reject or we fail to reject the claim. In the last example, the claim was in the alternative, so we were either trying to find evidence to support the claim or we failed to support the claim. So keep that in mind as you go through your homework problems. Thank you for watching, and I hope to see you in the next video.